Greetings and welcome to Lecture 5.5, the sum and difference of two cubes. In our last lecture, we discussed the difference of two squares. So if you remember, the difference of two squares looks like a squared minus b squared. Ultimately, we can factor that into a plus b times a minus b. Now let's consider x cubed minus 8. Which we can write it as x cubed minus 2 cubed. And y cubed plus 28, we can actually write that as y cubed plus 3 cubed. Now it would be lovely if we had something as short as sweet as the difference of two squares for the difference of two cubes and the sum of two cubes. But unfortunately, we just don't. So here's what we do have. We have two formulas that we can memorize. Okay? And here's kind of an easy way of memorizing them. A cubed plus b cubed is going to be a plus b times the quantity a squared minus ab plus b squared. Okay? So when you factor it, your signs will go plus, minus, plus. So you start with a plus, your second sign is a minus, and your third sign is a plus. So the only thing you have to remember is it does look like something like a minus b quantity squared, except there's no 2 out here. Okay? So here's how you memorize it. A cubed plus b cubed is a plus b times the quantity a squared minus ab plus b squared. Then we have a cubed minus b cubed. Your signs are going to go minus, plus, plus. So your first term is a minus b, and in your second term you have a squared plus ab plus b squared. Now, if you don't want to take my word for it, we can verify that these are true. So let's start with the a cubed plus b cubed. Well, if I do this multiplication, and I did this multiplication using column format, then I'm going to take b and multiply it to each one of these terms, and I end up getting a squared b minus ab squared plus b cubed. I'm going to take a and multiply it by each one of these terms, so that gives me a cubed minus a squared b plus ab squared. Well, those two middle terms drop out because they're opposite signs, therefore leaving me a cubed plus b cubed. Now let's verify that a cubed minus b cubed breaks down into a minus b and a squared plus ab plus b squared. So again, I'm going to use column multiplication. I'm going to multiply negative b to b squared, negative b to ab, and negative b to a squared, giving me negative a squared b minus a b squared minus b cubed. Now let's multiply a to all of the terms. A times b squared is ab squared, a times ab is a squared b, and a times a squared is a cubed. Adding these straight down, I ultimately get a cubed minus b cubed. Now that we have a formula to use, let's apply it. So we have x cubed minus 8. Now x cubed is cubed, but 8 is 2 cubed. Therefore, I can use remember the signs are negative, positive, positive. So that's going to break down into x minus 2 times the quantity x squared plus 2x plus 2 squared. But 2 squared is 4, so ultimately my final result is going to be x minus 2 times the quantity x squared minus plus 2x plus 4. Let's try another problem. Let's factor y cubed plus 27. Now 27 is 3 cubed, so we could write it as y cubed plus 3 cubed. So it's the sum of two cubes. So if you remember, our signs will go positive, negative, positive. So the first term is y plus 3. And in the second term, I'm going to take the first value, y, and square it. Then I multiply two of them together, so y times 3, but my sign is negative. And my last term, I'm going to square my 3. So ultimately, my final solution is going to be quantity y plus 3 times y squared minus 3y plus 9. So let's do a problem together. 64 plus t cubed. The first thing I want to ask myself, is that 64 a cube of something? And it is. So 64 plus t cubed can be written as 4 cubed plus t cubed. Now if you wanted to switch it around, you can. It doesn't make any difference in this case. So my first term is going to be 4 plus t, and my second term is going to be 4 squared minus 4 times t plus t squared. Now the only thing I need to do is that 4 squared. So my final answer is going to be 4 plus t. 4 squared is 16 minus 4t plus t squared. See, once you know the pattern, once you know the formula, it's pretty simple to break these down into its factors. 27x cubed plus 125y cubed. Now on first inspection, maybe you don't see that it's cubed, but I can rewrite it into the sum of cubes. So 27x cubed plus 125y cubed, I can write it as 3x cubed plus 5y cubed. And because I have the sum of cubes, now my first term is going to be 3x plus 5y. And in my second term, I square the first, 3x squared, subtract 3x times 5y plus 5y squared. Now all I need to do is do my multiplication and simplify if necessary. So 3x plus y, 5y, will give me 9x squared minus 15xy plus 25y squared. Once you know the secret, it's kind of pretty simple and straightforward. Yes, I know, I had to throw in an example with a fraction. And I know y'all hate fractions. But let's look at this fraction. It's quite simple. That 1 over 8, well, that's 2 cubed. So I can rewrite it as 8 cubed minus 1 over 8 will give me 8 cubed minus 1/2 cubed. Now I have my two numbers to work with. So I'm just going to follow my formula. A cubed minus 1/2, pardon me, not a cubed, a minus 1/2, a squared plus 1/2 times a plus 1/2 squared. Now let's just simplify that. A minus 1/2, a squared plus 1/2 a plus 1/4. And I'm done. Let's try one more problem. This time I'm going to try it two different ways. First one, for x to the 6th minus y to the 6th, I'm going to try using the difference of squares. So x to the 6th minus y to the 6th will be x cubed squared minus y cubed squared. Now my difference of squares is going to be the first term minus the second term. times the first term plus the second term. But now I have the difference of cubes and the sum of cubes, so I can break those apart separately as well. So now, just using my rule, x minus y times x squared plus xy plus y squared. And then for my x cubed plus y cubed, it's going to be x plus y times x squared minus xy plus y squared. And that's it. That's all I can factor for this problem. Now you may want to write it nice and neat. Put the smaller terms out front. X plus y, x squared plus y, xy plus y squared times x squared minus xy plus y squared. You don't have to do that, but maybe it looks a little neater to you. Now let's try using this, using the difference of cubes to solve the same problem. So x to the 6th minus y to the 6th will break down into x squared cubed minus y squared cubed. Now I have the difference of squares, so it's going to be x squared minus y squared times x squared squared plus the two terms multiplied, x squared y squared plus the second term squared but I'm not done yet. I do have to combine some stuff. That should be y squared. And I could break the first term down. I do know that that is going to be the difference of squares, which is x minus y, x plus y, and I get x to the 4th plus x squared y squared plus y to the 4th. But then I'm kind of stuck. No, I'm not too sure where else to go with this. I know the first term is a square. I know the second term is a square. But I'm not too sure how to get that middle term because it's not doubled. So I can't do that. Yeah. I mean, if this term went away, that would be one thing. I could kind of get right back up to here. But I don't see that it does, so I'm kind of stuck. So it's kind of nice to do this problem two different ways so you can see which is the better way. And to me, doing the difference of squares first, then breaking it apart in the difference of cube works better than trying the difference of cubed first, because we do get stuck. And as you see, the x to the 4th plus x squared y squared plus y to the 4th does indeed break down, but I don't know how to do it without a lot of struggle and without a lot of figuring it out on the way. So sometimes you might run into problems where you get this weird answer. Try a different method and maybe you'll get further in the problem than getting stuck at a certain point. So that's it for this lecture. Until next time, be seeing you.